All right, for this homework, the first question, identify the base you would use for each of the following transformations. The base we want to use is sodium ethoxide. So OET, if sodium ethoxide, I can draw the sodium there. We want to use this base because if our nucleophile attacks the carbonyl carbon, brings those electrons up and kicks off the leaving group, we want to have the same starting material we started out with. This needs to deprotonate the alpha carbon on here so that we can eventually get to a compound that looks like OET looks like this, so that once we have our nucleophile and we have other equivalents of starting material in solution, we can do our nucleophilic attack. If you're drawing out this mechanism, show these in individual steps, but I'm going to simplify it here and say that our electrons are going to move up to the oxygen, come back down, kick off our ethyl group, and that specific mechanism that I drew, now again I combined a couple steps into one, but that directly gets us to this product, where my methyl group, my CH3 right there, is right there. The bond that I formed between that carbon and that carbon right there is right here. My ester functional group became a ketone functional group. I had an ethyl group attached to that, so that is that ethyl group. And I still have my ester functional group on this side, which is right there. So that's a quick way to visualize this mechanism to show what products you're going to get if you're asked to draw the product. In this case, attached to my carbonyl carbon, part of my ester functional group is an OT-butyl group. So in this case, my base is going to be that compound there. All right, if we do a Claisen condensation reaction, we know that we're going to have another compound that reacts with itself. In this case, our base is going to be OET with a negative charge. If we deprotonate this, we take one of these protons to make the following conjugate base. So we've got our benzene ring, we have our O-ethyl group there. This carbon right here, if we deprotonate this, would have a negative charge on it, so that is going to attack that carbon there. If we push these electrons up and kick off that leaving group, then we end up with our benzene ring. We still have that CH2. We have our carbonyl carbon. We lost our O-ethyl group, but we did bond it to this carbon right here. Attached to this carbon right here is a benzene ring and another and a carbonyl carbon, which is our ester functional group. So attached to this carbon right here is a benzene ring, our aromatic ring, and then we also have our ester functional group, so our OET. All right, another good idea, another good way to do this one is the same way we did the last one. So if we have our T-butyl group there, we deprotonate that, and then we still have our ester functional group there, our OME, so that means our base needs to be our sodium methoxide. That would deprotonate that proton to get us to this carbanion. That can do a nucleophilic attack there. That can come up, come back down, kick off that leaving group. So we have our T-butyl group there. That's all there. We have our ketone functional group. Now attached to that ketone functional group is that bond that we just made. Attached to that carbon that attacked our carbonyl carbon, we have a T-butyl group. And we have our ester functional group with our methyl on our oxygen. For the next question, this gets us actually back to the arrangement that we had in the first question. So for this, if we deprotonate our alpha carbon with our OET, then we get the deprotonated version of this. So we've got a 5-carbon chain there, deprotonated version of this. If that does a nucleophilic attack on that carbon, those electrons come back down and kick that off. We're going to have our 5-carbon chain there. So our 5-carbon chain there. That methyl group comes up. we lost our O-ethyl group, but we formed a bond between this carbon here and that carbon there. So I'm going to draw that bond between those two, and attached to this carbon, we have our pentane chain. There, and then we also have our ester functional group. And then for the last question here, if we deprotonate one of these alpha carbons, it doesn't matter which one you do, we're going to then do a nucleophilic attack on the other ester functional group that is present in that ring. These electrons will come up, come back down, and we will kick that off. We're going to form a 1, 2, 3, 4, 5, 6-membered ring. So I'm going to go ahead and draw the 6-membered ring here. And let's say this is carbon number 1, so I'll go ahead and draw my ester functional group coming off of carbon number 1. And then on carbon number 3, I've got 2 methyl groups. So on carbon number 3, I've got 2 methyl groups coming off of that carbon. And then we've got 4, 5, and then on carbon number 6, so 3, 4, 5, 6, we have our ketone functional group. So that was the carbonyl of our ester. We attacked that, kicked off our ester, and we end up with a ketone functional group.